Uh, Good afternoon, learner. I welcome you all to this live session of this course, Engine and Gas Turbine. I request you all, if you have any question, to post your question in the chat box so that we can start, discussing them. Those who you are present in this session, I request you all to post your question in the chat box so that we can discuss these questions one by one. Any questions if you have, kindly post your question in the chat box. In this course, I think in part I have discussed about the internal combustion engine part, and my colleague Professor Vinay Kulkarni has discussed about the gas turbine part. So if you have any question from the internal combustion engine part, kindly post in the chat box so that we can discuss. I have seen the number of enrolled learners is near about 4,400. So this subject, internal combustion engine, is the core subject to all mechanical engineering students, and also it is core subject to electrical engineering, chemical engineering. And I request, if you have any question, to post them in the chat box so that I can discuss one by one. When we will get detailed assignment solution, because assignments are given for your practice. If you have any problem with any particular problem, please do let us know. We shall try our best to help you. In fact, assignments are given for your own practice. If you have any problem with any problem, please do let us know. We shall provide you the solution. Else you have to wait. We shall try to upload the solution of the assignment. If you would like to discuss the if you'd like to discuss any question from the assignment, you can discuss it now, if it is from the internal combustion engine part. So spark advancing and spark retarding, that it is related to the spark ignition engine, SI engine. So spark advancing, that when a flame is produced, that flame will traverse from the the regime where it is produced to the entire chamber. And sometimes because that we have discussed about the flame speed, the factors which affect the flame speed. So if there are vortices which are formed inside the combustion chamber, so that vortices will try to retard because of their inherent motion. the vortices will try to retain the flame front, and in that way the overall speed can be controlled. So the spark advancing and spark retardation, this is important phenomenon to have the flame speed control, and that we have discussed in the context of SI engine combustion. Spark advancing means flame is produced, that is the that flame will coming from spark plug, that is the visible flame. So that is the initiation of combustion, and that flame will traverse from the zone where it is produced to the entire space of the combustion chamber. While it is traversing, that is advancing, sometimes we need to have spark retardation, because that particular aspect we have discussed in the context of spark ignition engine combustion. And if, because the entire flow scenario inside the combustion chamber is highly turbulent, so when the vortices are formed, that vortices are trying to retard the spark because of their inherent structure, and the overall consequence of that particular phenomenon is very important in the context of the spark ignition engine combustion to prevent the detonation or knocking that we have discussed. If you have any more questions, please post that question in the chat box. If there is any question from the learners, kindly post your question in the chat box. For proper atomization and vaporization of the fuel, high injection pressure is required or high velocity of spray is must. See, question is proper atomization and vaporization of the fuel, high injection pressure is required or high velocity of spray is must. So you know that proper atomization is very important part of the design of the fuel nozzle. So proper atomization is important essentially to ensure that the combustion should be efficient. If the spray velocity is very high, then what will happen, that so that means to have the proper atomization, both the pressure and velocity should be controlled. It is not a case that only high velocity can control the atomization and also high pressure can control the atomization separately. So these two are the very important aspects to be considered for the proper atomization as well as vaporization of the fuel. If the atomization is proper, then vaporization will be also proper. If the atomization is not proper, then it is very difficult to have proper vaporization. How to Morse test? It is mode test. How to Morse test? So basically, Mr. Akshit Son, you are asking this question. This is commonly done in the practical course of any undergraduate mechanical engineering or electrical engineering subject. So any lab, if you go to, if you are having course curriculum, lab course, there you will find this particular test. This test is conducted to just to measure the efficiency of the internal combustion engine. So that, I mean, indicated horsepower, probably you are familiar with the word indicated horsepower, brake horsepower. So how to measure all these? Essentially to calculate the efficiency of the internal combustion engine, performance of the internal combustion engine, this test is conducted. In this course curriculum, it is not allowed to discuss about the details of this particular test, but you will find it from any standard book, and this is also there in the lab course curriculum of the undergraduate mechanical engineering and electrical engineering discipline. If you have any question, I would like to request you to post that question in the chat box so that we can discuss. What is the ideal spray con angle required? You know, that is, I have discussed in the class, if I can recall correctly, and it is basically depends on the shape of the combustion chamber. So ideal spray con angle is the, you know, very important aspect only to ensure that whenever we are getting spray pattern, that spray pattern should be most desirable to reach the, you know, remote places of the combustion chamber, to ensure that the spray fuel should reach in the form of a spray to several parts of the combustion chamber. This ideal spray con angle is important. It all depends on the size and shape of the combustion chamber. Mr. Ghosh is asking one question: what is the importance of firing order in SI engine? Firing order in SI engine, you know, I mean, is the question is related to testing of SI engine, or if the firing order of SI engine you are asking, then are you asking this question related to multi-cylinder engine? So if it is multi-cylinder engine, or if, I mean, then firing order will be important. Otherwise, if it is single cylinder engine, there is no question of having firing order. Let me tell you one important thing. You know that I have also discussed this part in one of the lectures. I am unable to recall the lecture number. In the multi-cylinder engine, you know, when there will be ideal stroke in one engine, there should be power stroke in other engine. So to make sure that at a given time in all engine cylinders, stroke is not the ideal stroke or strokes are not the power strokes, the firing order plays an important role. So whether it is, you know, multi-cylinder engine, I mean, this engine is having multi-cylinders, then firing order becomes important, considering the fact that when power stroke is there in any particular cylinder, in the remaining cylinders the other cylinders may have ideal strokes. So this is done to ensure that there should not be any rough, you know, motion of the piston in a shaft in which all cylinders are connected. So to have smooth, you know, motion of the shaft, it is ensured that when there will be power stroke in one cylinder, other cylinders should have ideal stroke to ensure that firing order becomes an important. I didn't get your question. AIFT technology using IC engine. I didn't get your question. So I think Mr. Ghosh, the answer to your question is firing order is indeed important for the multi-cylinder engine only to ensure that the, you know, piston, are connected to the common shaft, so there should not be any jerky motion in the common shaft. When there will be the power stroke in one cylinder, remaining cylinders ideal stroke will be there in the remaining cylinders. So that is why this is maintained firing order. I request you all to go through the lectures. If you have any questions, it is not mandatory that you have to ask that particular question during the live session. You can email me. I will get you back uh, with the answer, and also if you have any other doubts. How engine speed affect carburation? Let me tell you one important thing. Carburation is nowadays almost obsolete. So this carburation is not there, but if you have understood the fluid mechanics part properly, you will understand how the engine speed will affect the carburation. So what is the basic need of carburation? Carburetors are used to supply homogeneous mixture of air and fuel, and you know that I have discussed that there is a venturi, and in which when air is allowed to pass, because of the sudden contraction air velocity increases, pressure falls, and the air speed is totally dependent on the engine, the speed of the engine cylinder. So engine speed in a way directly affect the carburation. So question is, the main purpose of providing carburetor is to provide homogeneous mixture of fuel and air. Air is taken from this surroundings. When air is approaching the venturi, because of the sudden contraction of the area, air velocity increases, pressure falls, and that pressure difference, that is the pressure at that moment inside the venturi and the fuel tank, leads to the flow of fuel from fuel tank into the venturi. Now question is, the engine speed directly affect the airflow, and hence it will directly affect the carburation. So it's very easy to understand. Okay, explain about advancement of internal combustion engine in future scenario, because the present scenario electrical vehicle and Tesla motor is the future. If that is the, because I am not here to discuss this question, I really do not know why you are asking this question in this forum. Internal combustion engine is the future scenario, because yes, you are correct, electrical vehicle and Tesla motor is the future. But let me tell you one important thing. I really do not know how much time even this particular technology will take to have the heavy vehicles. So the power that you need to drive the heavy vehicles, whether that power will be available from the electrical vehicle or Tesla motor, I really do not know. Second thing, though internal combustion engines, the combustion of fuel produces, NOx and other gases which create air pollution, but electrical vehicle is also very much susceptible to the severe air pollution. So I am not going to discuss the merits and demerits of these two, but as of now, internal combustion engines, internal combustion is very much needed for the heavy vehicles, that you have understood, I guess. What is the approximate Reynolds number maintained in SI and CI engine? See, question is approximate Reynolds number. Reynolds number of what? I really do not know which you are talking about. I can tell you I can give you hints. See, if you would like to calculate Reynolds number you can calculate, because you know the. Would you like to calculate Reynolds number of the air when it is flowing through the intake manifold? Would you like to calculate the Reynolds number of the combustion products that is there inside the combustion chamber? Now, whatever is the case, what you need to do is that you need to calculate, if you are interested in the Reynolds number of the combustion gases which are there in this combustion chamber. you have to have the density and viscosity of the gas mixture. Once you calculate density and viscosity of the gas mixture, you can understand the RPM of the engine cylinder. From there you can calculate what would be the velocity, because you know the crank radius. So from there you can get the velocity, and you know the cylinder diameter. From there you can calculate what would be Reynolds number. For your information, I am telling you, when there is exhaust stroke or the power stroke, considering the velocity that is there inside the engine cylinder, the underlying flow is highly turbulent. So now you can imagine what would be the typical value of Reynolds number. Learners, if you have any question, I request you all to post your question in the chat box. If the question is pertinent one, I shall be happy to discuss that particular question. I hope, Mr. Ghosh, you have understood exactly what I wanted to tell. So, Reynolds number maintained in SI and CI engine, I have given you hints that when in particular the stroke is exhaust stroke or the power stroke, that time the flow scenario inside the combustion chamber is not laminar, it is turbulent, and we also need to maintain turbulent flow by creating some special arrangement, because the Reynolds number, that speed will affect the that engine speed, how the, because this is maintained, that will provide an avenue to control the detonation and knocking. That part I have discussed when I have discussed the combustion of SI engine. How does the load on the engine is related to fuel consumption? What is the relation between them? See, engine load and fuel consumption, these two, this is very trivial. You may ask yourself. I mean, you know that mass flow rate of fuel by mass flow rate of air, that is fuel air mixture, versus engine load. If you plot, you will find three distinct regimes. Idling zone, cruising zone and power zone, that I have discussed. So mass flow rate of fuel and mass flow rate of air. So the fuel consumption, this is very trivial definition, you will find it from any standard book of IC engine. So if you would like to have high engine speed, when it is required, depending on the load, right? So that means if you need to have load, that means whether it is a cruising zone or power zone, depending on the zone in which the engine will operate, based on that the fuel consumption will be decided. If you try to recall, in the cruising zone and in the power zone, the fuel consumption rate is much higher than the cruising zone. Let me tell you once again. During the idling zone or idling period or the power zone, during the idling zone of operation, when the internal IC engine is in operation, during both idling and power zones, fuel consumption is much higher than that is needed during cruising zone. Why? Because idling zone, that engine is still on, but there is no load extracted from the engine. In that time, fuel consumption rate is very high. Also in the power zone, because you are extracting more load from the engine, definitely fuel consumption rate should be high. So this is very trivial, and that plot I have discussed, you will get it from any standard book. How exhaust valve location affect the knocking in SI engine? See, exhaust valve location affect the knocking in SI engine. You first have to understand what do you mean by knocking in SI engine. What are the factors that affect the knocking in SI engine? If you place the exhaust valve, then what, in which way it can modulate the knocking in SI engine. So these are the aspects you have to understand first. What is the difference between knocking and detonation? See, again you are asking a very trivial question over here. Let me discuss about the first question. What should be the ignition procedure in case of a dual fuel engine? How different ignition temperature fuel is managed for the process of combustion? How different ignition temperature of fuel is managed for the process of combustion? Different ignition temperature is managed for the process of combustion. See, you know that if you are, I really do not know why you need to have different ignition of the fuel temperature. Would you like to mean that when two different fuels are blended together, if the fuels are blended together, somehow you need to ensure by varying the chemical composition is that that particular aspect should not be the dominating in the context of combustion. That you have to understand. Detonation and knocking, let me tell you, these two are the undesirable phenomenon in the context of internal combustion engine operation. So you know that when the flame front is advancing, I have discussed that maybe when the engine is in operation, after a few cycles of its operation, the several spots like exhaust manifold. Someone has asked me a question few minutes back. So exhaust manifold will be acting just like a spark plug after a few cycles of the operation of the engine. So in that case, whenever we are discharging new charge, we are introducing new charge to the cylinder, the main flame will produce from the spark plug, there is no doubt about it, but several other spots like exhaust manifold may act as the artificial spark plug. So from there another or secondary flames will propagate. Secondary flames will produce. Those secondary flames will proceed. They will try to collide with the main flame, and that produce I can say undesirable phenomenon. So that is, what is called is. So when the extent of that event is very severe, then sometimes the situation goes beyond the control, and these two are known as detonation and knocking. So basically, first of all, you have to understand. I am not going to tell you because you should read. I have discussed this aspect in the class. First of all, the main flame will come from the spark plug. There will be a few spots which spots will act like the artificial spark plug after a few cycles of operation of the internal combustion engine. Secondary flames will produce and propagate, or will traverse along the rather in the opposite direction to the main flame front. So all these flames will try to collide each other. They will create an audible noise, and that particular phenomenon has got a special name. You should know what is the special name of this particular event. Now, when the situation is so severe that it goes beyond control, this phenomenon has also got a special name. So your duty is to understand these two events from the standard book. Those are available in the literature. I have given you hints, which is detonation, which is knocking. Students, learners, if you have any further questions, kindly post those questions in the chat box. We shall discuss. What is the operating pressure of a simple carburetor? See, Sarath, you are asking this question. What is the operating pressure of the simple carburetor? Simple carburetor. Simple float type carburetor I have discussed in the class. You have seen that pressure at the venturi should be below the atmospheric pressure. Only then the difference in pressure is the driving force for the movement of fuel from the fuel tank into the venturi. So what is the operating pressure? That means at the venturi the pressure should be less than the atmospheric pressure pertaining to the case of simple float type carburetor that we have discussed. Mr. Ankit, if you have any question, please post that question in the chat box. Operating pressure of simple carburetor, I told you I have discussed this particular aspect of the internal combustion engine considering a simple float type carburetor, and the pressure at the venturi should be less than atmospheric pressure, while the pressure acting on the fuel tank is the atmospheric pressure. So that difference in pressure is the driving force for the flow of fuel from fuel tank into the venturi. Multiple point port fuel injection system, yes, that is called MPFI. So multiple port fuel injection system is the modification over the fuel injection system, and this is done essentially to increase the efficiency of the internal combustion engine. At times it also reduces the the undesirable effect, that is detonation and knocking. I request you to think about, if you have multiple port fuel injection system, by how it can limits the possibility of having detonation and knocking. How rotary engine ignition compression is different from reciprocating type internal combustion engine. I didn't discuss about the rotary engine ignition compression, and hence this question is not relevant to this forum. What is the operating pressure range? Meaning, does port injection and simple carburetor have same operating pressure range? What is the operating pressure range? Simple carburetor, I have already given you answer to your question, that simple carburetor pressure range, that means, see, it all depends on the situation. I hope I really do not know whether you have completed fluid dynamics course or not. If you have completed fluid dynamics course, you should understand that the principle by which this carburation system works is the uh, pressure velocity coupling. So the main idea is to increase the velocity at the venturi. At the cost of that increase in velocity, pressure should fall, and that pressure difference, that is the pressure which is acting on the fuel tank, that pressure difference is the driving force to make the flow of fuel from fuel tank to the venturi. So now, depending on how much amount of fuel air mixture you need to have efficient combustion, this also depends on the load demanded by the engine. So demanded from the engine, all these aspects should be taken into account to decide what should be the pressure at the venturi to have the required fuel air mixture. Thank you, Professor Saha. I can understand you are there in this, forum. Thank you. Mr. Ghosh, we have discussed the spark ignition engine, we have discussed about the compression ignition engine, we have discussed about the SI and CI engines having unique compression ratio. So variable compression ratio, you have to look at the expression of compression ratio. What do you mean by compression ratio? From there itself, if you figure out the possibility of having the variable compression ratio, then the question will come how it can be functional in real practice. I can give you, hint that when you are asking about the compression ratio, you know that we have seen that efficiency of the Otto cycle and diesel cycle can be compared by looking at the compression ratio. Now there is another one cycle that is known as dual cycle. So this is neither purely Otto nor purely diesel. So it is combination of these two. So you can look at the operation of the dual cycle and you will get answer to your question whether it is possible to have variable compression ratio or not. Even if it is possible to have variable compression ratio, then how this particular aspect can be implemented to have in real practice. Yes, Mr. Sarad, you are asking how to distinguish the TS diagram of Otto and diesel cycle as they both appear to be the same on TS diagram. Thank you very much for this nice question. You know that when we are drawing the TS diagram, though apparently they both appear to be the same, but you know that in TS plane, this is the thermodynamic plane, and we have tried to represent all the processes those are there during the operation of the internal combustion engine. What are those different processes? One is the isentropic compression, then whether it is a constant volume or constant pressure process, that process is combustion. which is then the next process is the isentropic expansion and finally exhaust. So all these processes are mapped in TS plane by and you are telling that the TS diagram of both these cycles appear to be the same. Yes, but now see, when we are trying to represent the isentropic compression and isentropic expansion, the word isentropic is telling us that entropy is remaining constant, so it is a line parallel to t-axis. S is remaining constant. But when we are trying to represent the process, the constant volume combustion or constant pressure combustion, and finally the exhaust, that is blow down, I mean exhaust process from the exhaust process, we are also trying to represent those processes in TS plane. The fundamental difference is in the SI engine, combustion is constant volume combustion, while in the CI engine this is constant pressure combustion. So if you try to look at the PV diagram, you will find that for the CI engine the combustion process is represented by the constant pressure process. So the slope of the constant processes rather, that is the combustion process and the exhaust process, these two processes, though apparently they appear to be the same, but still there is a difference in the slope of these two curves. If you would like to get it, the exact slope of these two curves, you need to know the first TDS and second TDS equation. So basically what you need to do is you need to consider the TDS equation, and from the TDS equation, why I am telling first TDS and second TDS equation, because one case it is constant volume combustion, other case it is constant pressure combustion. So that Cp and Cv term will be coming into the picture, because the combustion process is a process in which heat is added to the system by burning fuel. Whether the fuel is petrol or diesel, in both the cases we are burning fuel and we are trying to add some energy in the form of heat to the system. And now since one is the constant volume, other is the constant pressure, so since Cp is not equal to Cv, because I am not going to discuss about the definition of Cp and Cv here, those you have studied in your basic thermodynamics course, but the slope of the lines which are representing the combustion process and exhaust process in TS plane is not same, though they are appear to be the same, but they are not same. What you need to do, you need to understand what would be slope. For that you need to consider the TDS equation. If you consider TDS equation, you will get the slope of the curve, and if you consider the actual slope and if you plot the actual curve, you will find the difference between the TS diagram. Learners, if you have any questions, shall request you all to post your question in the chat box. Mr. Ghosh, your question is, which is preferred, dry sum lubrication or wet sum lubrication in IC engine? Let me tell you one important thing, because you are asking this question. Thank you very much. But when you are using lubrication system in internal combustion engine, whether a particular system should be useful, that depends on several aspects. Now, dry sham lubrication or wet sham lubrication, lubricants properties together with several other issues. So, in that case, surface tension will play an important role. I request you to kindly look at the aspects of lubricants which are very important, which should be taken into account when a particular lubricant is selected for the engine lubrication. So whether it a dry sham or wet sham, which property of the lubricants will be important to decide this particular aspect. Learners, if you have any questions, kindly post your question in the chat box. We are having limited time, so shall request you all to post your question in the chat box. We are having another 10 minutes time for this particular session. Learners who are present in this session, if you have any questions, kindly post your question in the chat box so that we can discuss. Mr. Ghosh, you are asking one question. Could you please explain about stratified charge engine? This is not there in the course content, which is in which we are discussing. I mean, this is not the question. This particular aspect is not discussed in this course. If you have any special interest, you can write to me, or you also can get it from several other books, several standard books to be precise, on internal combustion engine. Learners, if you have any questions from the internal combustion engine part that I have discussed through several lectures, shall request you all to post your question in the chat box so that we can discuss. How can we select the category of lubricant oil rating such as CS, CP, CC, CD for diesel engine? See, again I am telling you, you all are your questions. What you are asking, these questions are not related to the topics that I have discussed in the through several modules of this course. If you have special interest, you can write to me. We shall discuss. You can email me. But this question I didn't discuss. I have discussed about the basic lubrication system, the lubricant properties, and also what would be the consequence if we do not provide lubrication system. Rather, the merits and demerits of the lubrication system in the context of the internal combustion engine operation. This is the course which is designed for the undergraduate students of mechanical engineering, chemical engineering, electrical engineering, and we have discussed about several modules, and we have also discussed about the lubrication system. We have discussed the need of the lubrication system in the context of the internal combustion engine operation. Then we have discussed about the lubricant properties. So when you are selecting a particular type of lubricant, particular category of lubricant, what are the at least required characteristics of that particular lubricant should have, that we have discussed. Learners, if you have any question, kindly put your question in the chat box. Kindly post your question in the chat box so that we can discuss now. We are having only 3-4 minutes. Shall request learners to post your question in the chat box if you have any. Yes, so now you are asking one question, that is perhaps you are trying to trust the fundamental aspect of the internal combustion engine. The previous questions that you have asked, those are very routine question, and perhaps a technician, even or the internal combustion engine operator can give you answer to the question. The question is, how can you calculate pressure drop per unit length? So first of all, you need to know what to mean by pressure drop, and you are trying to calculate pressure drop per unit length inside the engine cylinder. See, in thermodynamics, so internal combustion engine, that is one part of the applied thermodynamics. So the basic what we have understood from the fluid mechanics, thermodynamics, and heat transfer, our understanding from these subjects will be very much essential, rather are very much essential to understand the processes of the internal combustion engine. So had it been physical interaction, I could have asked you one question, that when we are trying to represent the process in TS or PV plane, is it really possible? Because if we take a particular point inside the internal combustion engine, if we select a particular point in the engine cylinder, then pressure, temperature will be something. If we take different points in the engine cylinder, we will be getting different points, different temperature. But we are trying to represent the thermodynamic state of the working substance by a unique pressure, unique temperature in PV and TS plane. How it is possible? So, answer to your question is, in thermodynamics, one definition is thermodynamic state. So, when we are trying to have the state, then we are trying to have, the definition itself is telling that the property is uniform throughout the system. But in reality that is not the case, because when there is combustion, when there is even compression, when there is expansion of the working substance inside the cylinder, pressure, temperature, volume, these are not fixed. They are changing spatially, they are changing temporally. So there will be spatio-temporal change in temperature, pressure. How can you calculate the pressure drop if you would like to traverse from one point to another point in the engine cylinder? How can you calculate pressure drop? You can calculate analytically using the ideal gas relationship that we have used to map all the processes in TS and PV plane. You can use. Otherwise, the most accurate one should be to go for the numerical computation so that you can calculate what would be the pressure drop. What you need to do is, you need to simulate the phenomenon computationally. You will be having a clear picture about the pressure, temperature inside the cylinder, and then you can calculate what should be the pressure at different points. If you know the pressure at different points in the cylinder, and if you know the length, I think it is even a class 8 student can calculate what would be the pressure drop. So learners, if you have any questions, kindly post your question in the chat box. Within 2-3 minutes, we will complete this session. Learners, if you have any question, kindly post your question in the chat box. Within 2-3 minutes, we will complete this session. Learners, if you have any question, kindly post your question in the chat box so that I can discuss quickly, because we will complete our session within 2 minutes. What is the difference between fuel air cycle and actual cycle? See, again, thank you, it's a very nice question, but let me tell you what is the difference between fuel air cycle and actual cycle. See, fuel air cycle and actual cycle. Let me tell you, in internal combustion engine, we are considering the only when we are trying to represent the processes, we are assuming the working substance as an ideal gas, just like air. But now you try to recall, even during intake stroke, the only components are the fuel and air. Mostly air, very small amount is the fuel. But at the end of the combustion, the working substance is not the air, it is the products of combustion gases. Yet we are trying to represent the expansion process and exhaust process using ideal gas relationship. So that is the fuel air cycle, but the actual cycle should not be, rather cannot be mapped considering the ideal gas equation. Okay, if we take reverse reaction in vehicle, the fuel consumption will be similar to idling, cruising or power. If we take the reverse reaction in vehicle, I really do not know what your question is meaning. What do you want to ask? If we take reverse direction in vehicle, the fuel consumption will be similar to idling, cruising or power. see, reverse direction means I didn't get, but let me tell you, the fuel consumption during idling, cruising and power, those are because of certain issues. Now, if you would like to reverse the direction of the vehicle, so reverse the direction of the vehicle, I didn't get your question, but is it the reverse of the which reverse? I request you to to write me the question in detail, then I will get you back with the answer. I will get you back with the proper answer of this particular question. So, learner, thank you very much. Thank you all. And I have tried my best to give answer to your question.